In this video, we'll walk through a few questions about a graph and talk through what some of these different words mean. So let's start with the domain. The domain of this function is going to be all of the x's that are represented. And we can see that that arrow at the far left is demonstrating that it keeps going and going and going. And what we would say is that the domain starts at negative infinity and then it ends at 1. And notice that 1 is included, so we would put a 1 with a bracket rather than a parenthesis. That's the domain. And then when I look at the range, you can see that the range, the highest point in the range is, oh, sorry, the picture keeps wanting to move. The highest point in the range appears to be 1, 2, 3. Let me name this point here to make this a little more clear. This point at the top would be the point x equals -2 and y equals 3. So the ordered pair, the point, so I'm not writing interval notation, I'm saying that this point is -2, 3. So what I could say about the range is that the highest number in the range is 3, but we could see that the lowest point in the range, because we keep going down to infinity, this arrow again is going down, the range would start at negative infinity and then go up to 3, and it would include the 3. Next, we could look at the zeros of the function. The zeros of the function are the values of x when y is equal to 0. Or in other words, where does the graph touch or cross this x-axis? And it looks like we cross at x equals 1, and it looks like we cross again over here at x equals -5. So our zeros, we could write them as an ordered pair and say -5, 0 and 1, 0, or we could just say that the zeros are x equals 1 and x equals -5. How do you evaluate f of -4.5? That means when x equals -4.5, call that right about here, what is the value of y? So when x equals -4.5, what is the value of y? And I'd say it's about here at this point, and we could call that y equals 1. The height of the function when x is -4.5, the height of the function is 1. Where is the function increasing or decreasing? I'm going to highlight with blue where we're rising. So we read a graph from left to right, and we could see that we're increasing from -infinity up to x equals that -2, because we've got that orange point that we discussed. So that's where we're rising. And then I'll use another color to highlight where we're falling or decreasing. We start decreasing at -2, and we decrease down to x equals 1. I overshot it just a little bit. And when we talk about increasing and decreasing, we stop decreasing at 1. But when we talk about increasing and decreasing, when we hit the point 1, we are no longer decreasing. So what we're going to say is we're going to decrease up to, but not including at 1. So we won't use brackets, we'd use parentheses. Next, we could look at the values for which a height of the function is less than or equal to 0. So the values for which f of x is less than or equal to 0 would be anywhere that the function's falling below the x-axis, so anywhere down here. And so the values for which f of x is below or equal to 0 would be from negative infinity up to, looks like this point is negative 5. So from negative infinity up to negative 5. And then again at the single point 1. Let me write that one out because that could be a little bit confusing as you look at it. We'd say the values for which f of x is less than or equal to 0. It's all the values for which the value of the function is below 0, so the height is below 0, or equal to 0. So we'd say from negative infinity up to this point, negative 5, or, oh wait, and you know what? I need to include that, don't I? I need to make a bracket on that because at negative 5, we're equal to 0, or, so I'll use the union symbol, or at the point 1. Now, even though we're in interval notation, if we want to say the single point, we can put it in set notation, or a set bracket. So these funny brackets with a 1 in it. A relative maxima or minima, that would mean a high point or a low point. And we can see that this point, negative 2, 3, gives us a relative maxima point, but the actual max value is 3. And we don't have a point that's the lowest. Sometimes a student will mistake this y equals 0 for a low point, but because there's nothing below it, no points below it, we don't call that minima. So we only have a relative maxima, and that maxima value is, maximum value is 3. The values of x for which f of x equals 3. The values of x for which f of x equals 3. When does y equal 3? Remember, you could think of f of x as being the y. So when is y equal to 3? Y is equal to 3 when x is equal to negative 2. So the value for x for which the value of the function is 3 would be x equals negative 2. And then finally, is f of negative 1 positive or negative? When I look for negative, x equals negative 1, x equals negative 1, it happens on this purple line I've highlighted, and the value of the function when x is negative 1, the value of the function is positive because it's above that x-axis. I know that this problem is challenging for some students, but if you took each piece alone, each piece on just all by itself, none of the pieces are really challenging. Work through it, practice it a few times, look at several examples if you're feeling unsure of it, of how to do any of these evaluations, but just look at each piece. Let's run through them one more time. The domain is all the x's that are used. The range is all the y's that are used in the function. The zeros of the function are the places where we cross the x-axis. F of negative 4.5, you could interpret that as saying when x is negative 4.5, what is y? Increasing, if we read from left to right, we're talking about where it's rising or going up, and decreasing, reading the graph from left to right, where is it falling? The values for which f of x is less than 0 would be the values that fell below, the values for x where y fell below 0, and when we say or equal to, we'd be talking about those two zeros that we found earlier. Relative maxima or minima is a point where directly to the left or right, when we evaluate it, it's a high point. So that happens up here at the high point. So there's a maxima of 3. The values of x for which y equals 3. Y equals 3 when x is negative 2. And the last is f of the negative 1, positive or negative. We find when x is negative 1 and evaluate the graph, and we see that the value of the graph is positive at that point. Try these examples if you need to. Watch the video a few times, run through those examples, and I hope that clears up this type of question just a little bit more for you.